Our project is phishing and DDoS attack detection using ML models. My project overview is phishing and DDoS attack detection. The purpose of the project is detect the phishing URLs and DDoS attack in real time using the machine learning models. So, by detecting phishing attack, we need to classify URLs as phishing or safe using the random forest classifier and gradient boost classifier. To detect the DDoS attack, classify the DDoS attacks based on the traffic features using machine learning models. How to detect phishing detection? Machine learning models use a random forest classifier and gradient boost classifier to detect phishing URLs. We can extract the features through URL like length, HTTP suspicious characters to predict the phishing threats. In this way, we can predict the real-time detection. So, DDoS attack detection can be classified into 4 ways. Machine learning models classifies the traffic into attack types using random forest classifier and gradient boost classifier. After that, it will detect the attack types like single fold, UDP float, HTTP float. In this way, it will be detected. Based on the packet rate and byte rate, the features will be classified. Overall system architecture, we are using the backend as Flask and the machine learning models random forest and gradient boosting for detecting phishing and DDoS attack. For frontend, we are using HTML, CSS and Jinja templates. Datasets, we are using phishing data and DDoS attack data. This is the coding part of my project. Here, first import the necessary libraries and models like the random forest classifier and gradient boost classifier to train the model. So initially, this is the main function of phishing detection. In this main function, we need to train the model with phishing dataset. Phishing URL, this URL can be converted into phishing URL futures. In this way, the phishing detection will be done. After that, we can print the confusion matrix and classification report. Here is the extraction function. This is the prediction function. In this function, phishing will be detected or safe will be displayed. This is the DDoS detection main function. In this function, we need to train the dataset with the CIC dataset, which look like this. Then we can train the both models, then evaluate the accuracy of the test set, then display the confusion matrix and classification report. In this way, DDoS attack will be detected through the various types. This is the app.py main file. This is the Flask file to display the outputs in the website. Here is the overall accuracy of phishing attack in random forest accuracy and gradient boosting accuracy 99%. This is the classification report. This is the gradient boost classification report and confusion matrix. DDoS attack overall accuracy is random forest accuracy 97%, gradient boost accuracy 94%. This is the classification report for random forest through the different types and gradient boost confusion matrix. This is gradient boost classification report. So now I move to the output. This is the dashboard of our project, network security dashboard for detecting phishing detection and DDoS detection. Suppose I am entering the URL for phishing detection. I am entering google.com, then analyze, then it should be showing this www.google.com as safe, and phishing detection will be safe. In this way, phishing detection will be detected through the future analysis, URL length, HTTP, and subdomain level. Then I move to the DDoS detection. Based on the packet rate and byte rate, it will be detected which type of DDoS attack. Suppose I am giving 400 and below. Then it will be shown 100% normal confidence. So the attack is normal. Suppose I will give 4. Then this type is ICMP flood attack type. So in this way, the attacks will be displayed in the recent activity. Then another feature is dataset analysis. In that dataset analysis, by giving any sample data, then data insights will be displayed. Now I am giving simple data, so that's why it's total samples of 20 and phishing ratio will be 55%. The remaining 45% are safe and 55% will be the phishing ratio. These are the overall features in the small dataset. Okay, thank you.